Hi, this is video number 23. I'll give just a short video in this time. I just want to give another view or different view of what we mean by positive definite and negative definite, and negative semi-definite as well as positive semi-definite. Yeah, that I mentioned in the previous video. So again, we consider the system x dot is equal to f tx, or you can look at in the more specific way as x dot as f xy and y dot as g xy. Okay, so if we consider a function, we consider a function v, which is xy, and x is a function of t, y is a function of t. So what you can see from here is that this x and y is you can consider it as a path. You can consider it as a path, and a point xy is moving along the path x and y. What does it mean? So it means that if you have this path, just give you the try to describe what's happening here. If we have a point xy, so point xy here moving along that path, so this path is given as x and y, and we have those function v of xy. We can regard it as a kind of a surface that containing those path. Okay, so if we consider the function v as a function of xy, and x and y depend on those t, definitely we can find the rate of change for v, right? So you can differentiate with respect to t. So dv dt, that give you del v del x dx dt plus del v del y dy dt, and with x dx dt and dy dt given here, so we can write this as a del v del x of f plus del v del y of g. Okay, so this is the key formula to the liapunov technique. The key formula to the liapunov technique. If you look at my previous definition, we also use similar idea, but just with different notation. Okay, so now we suppose that v xy is continuous differentiable function. Is a continuous differentiable function. Continuous differentiable function on a region that contain origin. So on a region containing the origin. So if we have if we consider this, let's say there's our plane xy, and we have a region. We have a region which contain not there, contain the points, the origin. Now if we vanish at the origin, if v let's say v is 0 0, if v 0 0 is 0, then we say v is said to be positive definite or positive type. Positive type. no, positive tie or positive definite. Positive definite if v xy positive for all xy different than 0, and negative definite if v xy less than 0 for all xy different than 0. Okay, so the first condition here, v must be 0. Now the first condition, and then if v is positive for all x and y, we call it as a positive definite, and if v is negative for all xy, then xy we call it as a negative definite. So, and also we say v xy is a negative semi-definite. Is a negative semi-definite. Negative semi-definite if v00 is 0 and v xy is less than 0. We have the equality here, less than or equal to, for all x, y different than 0. And we say positive semi-definite and positive semi-definite and positive semi-definite if v00 is 0 and v xy is greater than 0 for all x, y different than 0. Okay, this I think much easier way to understand. Yeah, if you compare with the in the previous video that I gave earlier, that we have a function phi that satisfy phi 0 equal to 0, and phi is continuous and increasing, strictly increasing function. Now, if you look at, for example, if you have, let's say, ax 2m plus by 2n. So if you consider that function, let's this function, our function xy is equal to that. Now for mn positive, let's say mn is positive. Of course, we consider the integer. Then, of course, in this case, v is positive infinite, positive definite. Yeah. Then, sorry, I got there. So if mn is positive and a and b are positive, then v is positive definite. Positive definite. Okay, and for m n for ab negative, then we have v is a negative type or negative definite. Negative definite. Right, and if we have the so if our function v xy of positive definite, and we have another condition that del v del x f plus del v del y g, which is this is a v dot, yeah, is negative semi-definite if that v is positive definite and v dot is negative semi-definite, then we call it as a liapunov function. For the system that we deal with. So which means that if you want to choose or to construct a function, a liapunov function, those functions must satisfy the positive definite as well as the derivative is derivative with respect to t is a negative semi-definite. So those liapunov function must satisfy those two main conditions. All right, so I think that's all for the definition, I would say, for the liapunov function and how to construct the liapunov function. Further detail I will give when we deal with the result theorem and so on. Okay, so for now I stop here. Bye.